Welcome back, Honors Algebra 2. I am feeling alive and more on top of my game than I was in my 5-4 part 1 video. So here we go. This is still 5-4. I know that other video was almost an hour long, and this is still the same section. So imagine that. Okay, so we're going to get into graphing logarithmic functions, and it's something that I think if you want to open up to your graphing exponential functions, it's something that we're going to kind of be talking about that as well. So, but we are going to see it here. And then we'll also be adding a little bit to our parent function table. I think it's going to be actually our last one that we're going to fill in. So a logarithmic function is the inverse, just like we talked about before, of an exponential function. To graph a logarithmic function, you can use the inverse of an exponential function, then invert the values from the table to graph the logarithmic function. Okay, so that's a lot of words, and we're just going to talk about it in terms of numbers where we understand it a little bit better. So before in 5-3, we talked about graphing parent functions of exponential functions. So that parent function was y equals a to the x power. And so we used our x values of -1, 0, 1, and then our y values were 1 over a, 1, and a. Hopefully you remember that from 5-3, which should have been last week. So just as a few side notes and important things to remember. First, remember a is any positive number. So the domain, remember, of an exponential, the domain was always all real numbers. And then the range of a parent function before any transformations was 0 to infinity. And then we had an asymptote. We had, for an exponential function, we have a horizontal asymptote. And the horizontal asymptote before any transformations was at y equals 0. Now, like we talked about in the last video, a logarithmic is the inverse of an exponential. And so the parent function of a logarithmic function is this. F of x is equal to log base a of x. And again, we can write it over here. Y equals log base a of x. So remember, if you guys remember from, I think it's 5-2. It's either 5-2 or 5-1. I think it's 5-2. I don't know. To get the inverse of something, when you're given a table, all we're doing is just swapping the x and y values. So if my x values are -1, 0, 1, for the inverse, the y values are going to be -1, 0, and 1. And then if my y values are 1 over a, 1, and a, then my x values for the inverse are going to be 1 over a, 1, and a. So all I did here was I swapped the x and y values. Now, to find the domain and range, well, if you guys remember, again, the domain of the original is the range of the inverse. So that means the range of the inverse is going to be also all real numbers. And then the domain of the inverse is going to be the range of the original. So the domain here is going to be 0 to infinity. Okay, now let's talk about the asymptote. So the asymptote, if we have a horizontal asymptote at y equals 0, and we're talking about the inverse, what type of asymptote do you think we're going to have for the inverse? And if you're thinking x equals 0 because we swapped the x and y values, you would be correct. And x equals 0, that means it's a vertical asymptote. Okay, so let's get into graphing. But before we actually get into the examples, what I wanted to do is add the logarithmic to our parent function table. So we are going to get our parent function table. So if you don't have your parent function table, pause and grab it, or just follow along with what I'm doing. So our logarithmic parent function is going to be f of x equals log base a of x, where x is 1 over a, 1, and a, and then my x values are -1, 0, and 1. And then I'm going to write my information over here. So we have a vertical asymptote at x equals 0. We have a domain of 0 to infinity. And then we have a range of -infinity to positive infinity. So I'm going to first graph in my vertical asymptote to start with. So my vertical asymptote is a vertical line at x equals 0, which is here. And so what I'm going to do is, just like up here, I graphed with a base of 2. I'm going to graph with a base of 2 also. So log base 2 of x. And we can actually you look at it with Desmos, but we're just going to plot the points. So that would be 1/2 is at -1. 1 is at 0. And then 2 is at 1. And so my graph looks like this. And so if you look at this one compared to this one, remember, it's that reflection over the line y equals x. And so it's like reflected diagonally across the graph. And that's exactly what this is. It's a reflection over that diagonal line. So, okay, let's get into our transformations, our examples here. So use transformations to graph, blah, 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 all of our normal stuff. So there's a few ways of doing this, but I'm just going to kind of it's really up to you. And I'm going to show you on this side here, I'm going to show you the optional way that you guys can do this. But I usually don't do this extra step. So it's an extra step. It's up to you if you want to do it or not. So when I look, okay, so my first problem is log base 2 of x plus 1 minus 2. So I look at the base and I think, what's the base here? So the base is 2. And so as an exponential, and this is the part that's optional, because sometimes a lot of people don't like to memorize like that extra thing. But like the extra parent function table, they just want to memorize this one, which is fine. So we would go f of x is equal 2 to the x. Write our table for the exponential. -1, 0, 1, just like we did in 5-3. It would be 1 over 2, 1, and 2. And so then to get our parent function table of our logarithmic, we would just swap the x and y values. So the parent function of the logarithmic would be log base 2 of x. And so we would just swap the x and y values. So it would be 1/2, 1, and 2, and then -1, 0, 1. So that extra step there, I feel like the orange is a little blurry. I'm going to try and I feel like that kind of helped. I don't know. So the orange is that extra step that you guys can do if you want to. It's basically, so you just have to know the exponential and then know that you have to swap the x and the y values to get the logarithmic. It's an extra step, but less memorization. It's up to you. I prefer just to start here and then go forward with my transformations instead of adding this extra table, because oftentimes what I see is forgetting to swap the x and y values. But just for, sake of seeing it, this was just, we swapped the x and y values. So whatever you guys feel comfortable with, you do you. Do what feels appropriate, for you to learn this. Okay, so we are going to start with, and notice just again, the base and the base are the same. And that doesn't look like a 2, but it sure is. Okay, so we're going to start with our transformations. So is that +1? Is that within the function or is that outside the function? And if you're saying that's within the function, you would be correct. This is within the function. And then when it's within the function, is it a change to the x or is it a change to the y? And it's a change to the x. And then when I look at that -2, is the -2 within the function or is it outside the function? And if you're saying it's outside the function, you would be correct. And when it's outside, is it a change to x or a change to y? And this is a change to y. So we can apply those in our transformations. So when we're doing our x values, now I'm just going to write 1/2 as a decimal. I prefer to use decimals when I'm going through this. When I'm changing my x, do I do the same operation or the opposite operation? And if you're saying opposite, you're correct. We're subtracting 1 from every single x value. When we see a plus, we do the opposite, we subtract. And then our y values, -1, 0, and 1. Our y values, do we do the same operation or the opposite operation? And we do the same. So I'm going to subtract 2 from all of my y values. And now I can get the list or get the table. I just got an email that said list on it. Okay, so 0.5 minus 1 is -0.5. 1 minus 1 is 0. 2 minus 1 is 1. And then -1 minus 2 is -3, -2, -1. Now, just like with exponential, I prefer to graph my asymptote first. Remember, my parent function asymptote is at x equals 0. So I look to see, how do my x values change? Well, we subtracted all of our x values by 1. So my new asymptote is going to be at x equals -1. And so we're going to graph that. So -1 is here. So I always start there. I always want to start with my asymptote and making sure I graph that first so I don't accidentally go over it when I'm graphing my curve. So then -1/2 is at -3. 0 is at -2. And 1 is at -1. And so my curve looks something like this. Okay, so what I want you guys to do is think about the domain and range. So pause me here, think about what's the domain, what's the range. and then come back and check your work. Okay, so you should be coming back to check your work. The domain here, left to right, we're starting at, it starts at -1, but it doesn't touch -1, so it's going to be a parentheses to positive infinity. And then the range, always for logarithmic, is all real numbers. Bottom to top, infinity or negative infinity to positive infinity. Now, a trick with domain. The domain is something, and I'm going to actually write it up here as well. A little trick is you can find the domain by setting the argument greater than 0. So, like, because we know the parent function is always going to be like 0 to infinity, to find, I should rewrite this. I should say this better and with better English. So to find the domain of a transformed function, set the argument, which, remember, the argument is like this part of the log, this part of the log, this whole part of the log. Sorry, set the argument greater than 0. So what I mean by that is, let's try and get this all in here. With this, the argument here is that x plus 1. So I'm going to take that x plus 1 and set it greater than 0. And then I'm going to subtract 1, and x has to be greater than -1, which is exactly what we got here. So without looking at a graph, I could find the domain of all of these like logarithmic functions just by looking at the argument. So just like a shortcut, not a shortcut, but like a different way of doing something if you don't have the graph in front of you. Okay, so let's look at 2. What I would like you guys to do is just look first at 2 and figure out what's my parent function table, and write that out. So pause me here, think about your parent function table, and write that out. So you should be coming back. You should have thought, okay, my parent function is just the simplest form. It's log base 3 of x. So that means, and you know what I do when I'm doing this, because like I said, I don't do this extra step. If you did, totally fine. You would have written an exponential table for 3 of x. But what I usually do is I actually kind of do that in my head. I'll write the y values first, and then I think, okay, so that's going to be 1/3, that's going to be 1, and that's going to be 3. However you want to do it. If you want to, know this table, great. If you just want to know this table, fine. Like however you want to memorize those parent function tables. Okay, so then what I want you guys to do, you have 2 transformations here. So I want you to apply both of your transformations to your parent function table, and then I want you to come back and check to make sure you have the same table as me. So as you can see, one of our, the negative is going to be a change to the y values. It's on the outside of the function. And then that -4 is inside the function. So that's going to be a change to the x. So now we are going to apply that to our parent function table. Okay, so I applied my transformations there. And so remember, x, change to x is opposite operation. Change to y, we do the same operation. And so then I can get my new table. And now I have my new table. Look at that magic of the video. So now you should be coming back to make sure, did you have that same thing as I did? Hopefully you did. Now let's do our vertical asymptote. So remember, our vertical asymptote starts at 0. All of our x values changed by 4. So my new asymptote is going to be at x equals 4. So okay, so now I can plot my points. So 4.33 is at 1. 5 is at 0. And 7 is at -1. So remember, this negative caused a reflection. And so instead of it being a curve like this, it's actually now a curve like this. Okay, so now what I want you guys to do is pause and think about what's the domain and what's the range of these two, or of this graph. So it's the domain, what's the range? So you should be coming back. The range should be easy. The range doesn't change. -infinity to +infinity. But the domain does change. So you can do it one of two ways. Look at the graph. We know it's going to be 4 to infinity. Or we can set the argument, x minus 4 greater than 0. Add 4 to both sides. I get x is greater than 4. Okay, and that is it for those first two examples. And then we're going to get to the next two. Okay, so now we're dealing with natural log. Remember, this is the same as log base e. So use that. We're going to use that when we're dealing with our parent functions. I got to get paper under this because it's a weird table underneath. Okay, so let's start off with our parent function table. So I'm going to actually write it log base e of x, just so we remember. These are the same things, right? So that tells me when I set up my parent function, my y values, those are always the ones I put in first, -1, 0, and 1. And then my x values are going to be 1 over e, 1, and e. So I usually will do those in the calculator because I don't like to think about those. And that's 0.37 and 2.72 because I like to have my decimals when I'm graphing. And then I think about what are my transformations. So I have this negative. Is the negative within the function or is it outside the function? And it's within. So when it's within, is that a change to the x or is that a change to the y? And that's a change to x. And then we have the plus 1. And is the plus 1, sorry. Is the plus 1, had to drink coffee. The plus 1, is that within the function or is that outside the function? And that is outside. So that's going to be a change to y. Okay, so let's plug those transformations in. So when it's a change to the x, is it the same operation or is it the opposite operation? And it's opposite. So what we're going to do, instead of multiplying by -1, we're going to divide all of my x values by -1. So we're going to have 0.37, 1, and 2.72. And then we're all dividing these by -1. If you want to multiply by -1, gets you the same thing. Okay, so then to all of my y values, I look at this plus 1. Remember, my y values, do we do the same operation or do we do the opposite operation? And we do the same, so we're going to add 1 to all of my y values. And now I can get my new table. 0.37 divided by -1 is just -0.37, -1, -2.72. -1 plus 1 is 0, 1, 2. And then I want to draw my asymptote. Remember, my asymptote starts at 0, Well, 0 divided by -1 is still 0. So this one does not change. So it's going to be here, which is hard to see. I'll draw my arrows nice and big so you can see that. And then we're going to plot our points. So negative 0.37 is over here at 0. Negative 1, 1. And then negative 2.72, 2. And so what this happened, this negative on the inside caused a reflection over the y-axis. And so my graph, instead of it being a curve like this, it's a curve now like this. So my vertical asymptote is still at x equals 0. And then what I want you guys to do, just like before, think about what's your domain and range. So come back after you've thought about it, you have your answers, you know what you think it is, and check your work. So range is always easy. Negative infinity to positive infinity. Domain, again, 2 ways of thinking about it. We can think about it left to right. Left to right, it's going from negative infinity to 0. It doesn't go past it, and we use a parentheses because it doesn't hit it. Or we can do that little trick. We set the argument, which is negative x greater than 0. But then when I divide both sides by a negative, I have to flip the inequality symbol. And so that's why it gets x is less than 0. Either way you want to do it is great. Okay, so what I want you guys to do is I want you guys to try for every single thing on your own, come back, check your work. So I'm going to do it kind of piece by piece by piece, just like I did on 2. And then you guys can check your work kind of throughout. Or just fast forward me and go to the end and make sure you did it correctly. But pause here, try as much as you can, and then come back and see how you did. Okay, so if you're coming back, first thing we always think about is what's my parent function. My parent function here is log base e. So or log base e of x, I guess. So I'm going to write my parent function table. And there it is. Now I'm going to think about my 2 transformations. So I have 1, the -1 is a change to the x, and then I have that -3 is a change to the y. So now I'm going to put those into my table. So I put my transformations into my table. Remember, change to x is opposite operation, so I added 1. Change to y is same operation, so I kept it the same. And now I have my final table. So I have my final table. My next step is to think about where is my new asymptote at. All of my x values were added by 1. So I added 1 to my asymptote to get my new asymptote at x equals 1. Now I'm just going to graph my points, and I now have my curve. Last thing to do is think about my domain and range. Range never changes. Range is always all real numbers. Don't even have to think about it. Domain starts at the asymptote, goes on for infinity. Remember the shortcut? We can set x minus 1 greater than 0, add 1 to both sides, and I get x is greater than 1. So that's it. So that wraps us up for 5-4. So that's 5-4. Again, if you guys have any questions, you need any help, come by office hours, text me, call me, whatever you guys need. I'm happy to help you in any way. I hope you guys are having a great day, and I will talk to you soon. Bye, guys.